So adjacent angles. Adjacent sounds like a really big fancy word, but it's not actually that bad. It means something very simple, actually. So if I say my house is adjacent to a CVS, which is not true. I like to tell you guys when what I'm saying is not true. If I say Mr. Bunger is adjacent to the wall, I could say Zach is adjacent to Divine. Zach is also adjacent to Eminol, but Eminol is not adjacent to Divine. What am I saying? If you pick it out via context clues, what do you think adjacent means? Eli? Next to. Now, even more, when we get down to the geometric meaning, it does mean next to, but it means something even more specific.
Yeah. It has the stem ad in it.
Ooh, it does have the stem ad. What's the stem ad mean?
Two.
So it's
Next to.
it's next to. And when we get to the geometric definition, it's next to and sharing. So adjacent objects in geometry share something. So what if I tell you these angles are adjacent angles?
Dude, that's mine.
What are they sharing? Thomas?
They're sharing one line thing.
They're sharing one of their rays, one of the sides of the angle. Come on, Smarting.
You can do it, Smarting.
So they're sharing this side, and they're also, Bunger?
They're also sharing a vertex.
They're also sharing the vertex. So when we talk about adjacent angles or adjacent shapes, we always have to look at, well, what are they sharing? Adjacent angles are going to share the one side and the vertex. So now let's look at this. BAC, my big angle here, measures 100 degrees. Identify at least 3 things that we know about BAD. So BAD is my small angle here. And BAC, which is my smaller angle there. What are some things we could identify about them? Some statements we can make. Karina?
That the BAC is
Um, yeah, BAC is obtuse. That works, but since it tells me it's 100, that's kind of easy. I do agree with it, though. What about the, by the way, yesterday I think I forgot to mention, if I put an M in front of my angle symbol, anyone figure out what that means? That means the measure. So it's talking about how big is it. So the measure of angle, let's talk about angle bad.
Bad angle.
The measure of angle bad will be less than, what do we know it's got to be less than?
100.
It's got to be less than the 100 degrees. We also know that the measure of angle DAC is less than that 100 because they're both inside of the 100. Thomas, what else could we say?
We could also say that angle BAC is equal to angle angle bad plus angle GAC equals angle BAC.
Exactly.
And also adjacent was one of our vocab words in language arts.
Very nice. I like the cross-curricular or cross-content connections. So the big thing here with adjacent angles is those two angles will have to add up to give me that 100 degrees. So what if I tell you that DAC is 30 degrees? Oriana?
BAD would be 70.
Yeah, BAD would then be 70 degrees. It will be whatever the difference is between them. So that actually looks bigger than 70. It looks bigger than a right angle, actually. But if I told you that my small angle is 30, my big angle would have to be 70. Now, if I told you that my small angle was 15 degrees, which is closer to what it actually looks like, If that was 15 degrees, what would BAD end up being then? What's the difference between 15 and 100?
85.
85. So that would probably be closer to what it actually is. But again, you cannot trust just what you see. You have to trust what you're told. So be careful, like looking at the angles. Sometimes they will look deceiving. I did not get a copy of these. So I want you to highlight, circle, star something to remember. Share a vertex, and they share a side. What's it mean that they have no interior points in common? Talking to the same people, Luke.
All their angles are different?
Their angles could actually be the same. Like up here, AOB looks pretty close to BOC. They might be equal to each other.
But they're not.
This is kind of complicated. Well, it's hard to just infer what they're saying. What they mean by having no interior points in common is if I draw a big angle and then I draw another angle inside of it, say I have angle ABC and then angle ABD, ABC and ABD are not adjacent. They do share the side right here, and they do share the vertex at the bottom, but if ABC is my big angle and ADB is this angle, what that really means is cannot be inside each other. They have to be B-side, not inside. So they want to be B-side, not inside.
You're confusing me.
So these angles, AOB, is right here. This distance between that ray and that ray. BOC is this one. So notice they're B-side each other. But if I come over here and look at ABC, my big angle here, and ABD is inside my bigger angle. This cannot be adjacent because it's inside. If I draw a different ray and I come out this way and say we make this ABE, and that is, let's say this angle arc right here. Notice how now my green is not inside of my red. So EBA and ABC could be adjacent, or EBA and ABD could be adjacent, my green and my blue, but red and blue cannot be adjacent because blue is inside of red.
Oh.
Make sense now? Thank you for asking the question. It's good to go over it again. Eli?
So is Divine A and Zach is D and Emil is
We can't really think of it like that because angles, we can draw them inside of each other. So if like, say Emino like sat on Zach's shoulders or something weird like that, yeah. So, but we don't want to do that. We don't want to injure anybody. So just remember, they want to be B-side, not inside. Bunger?
That mean our previous angles weren't adjacent?
The ones from the launch?
Yes. Because they're one's inside of the other.
So we were looking at this angle
Yeah, but then
and
there's
this angle.
But then there's also BAC.
So BAD and DAC are adjacent. But BAC and CAD cannot be. If we talk about the big angle, that is not adjacent to anything because it's the big angle. I would need to be beside something. So blue is adjacent to green. Nothing's adjacent to red because they're inside of it.
That makes sense.
Cool?
Yeah.
Okay.
Thank you.
Thank you for clarifying. I appreciate that you guys are asking more questions, it seems like.
You're welcome. It's our specialty.
Alright, so on your paper, I want to see how good we are with what we just covered briefly. So I want you guys to, and you can look up here if it's hard to see on your paper, but ooh, I made it better this year. Last year it was hard to see on the notes. I forgot that I made these notes better this year. So look for adjacent angles, and some of them have more than one option. You want angles that are adjacent. So our first one, I'll help you with the first one, then I want you guys to do B, C, D on your own. FAD. Remember to always, the middle letter tells you where the vertex is. So I'm at this vertex. I start at F, go to A, and go to D. So I'm this arc right here. I like to color in the arc so I can see it. So if we look for an angle that's adjacent to that, anyone know it?
Is it?
Eminal.
FDG or
Ooh, FDG would be this angle. Remember, they have to share the vertex.
Oh, yeah.
That does not. So any angle that's adjacent will have a vertex of A because it has to share the vertex. Isaiah? FAB is this angle, so that won't work because it's putting one angle inside of the other angle.
Oh,
Layla?
Is it
GAB works because it's this angle. But we could also...
what?
I was thinking FAB.
Oriana.
And then DAB?
DAB is the exact same angle. So we could either call it GAB or DAB. They're both the exact same angle. Because notice GAB does that. DAB does that. It's the same angle, just one takes the ray out further. Does that make sense now? So try B, C, and D on your own. If you're having issues, please stick up a hand so I can help you. Probably going to give you a minute on this, because if you're struggling, I don't want you to be too worried. We're going to use cards now because you guys are stressing me. Yeah. Yes. Now, when I draw these, you want to go from one ray to the other ray. Don't start in the corner how you kind of came out. So if that's your angle, then you can see that this angle is right beside it, sharing the same vertex. G is your vertex though, so it would actually be HGE or C. Did you say CGH? Yeah, so CGH works, EGH works, HGE, HGC. I mean, there's a lot of ways that we can name it. They're all the same angle. So guys, there's lots of ways to name the same angle multiple ways when they share points on the same ray. We've talked. Divine is out of the room. Isaiah, what do you think? An angle adjacent to BGC. So now if I look for an angle adjacent to BGC, I first want to identify where BGC is. So start at B, go to G, go to C. This angle right there. What's adjacent to it? HGC is this angle right here. That will work. Are there more? Crystal? EGH is the exact same angle. So I'm going to write that in green just right below here. EGH. Because they share that vertex. That's the same as going from C as going from E. So good. It's another way we can name it. But there's actually another angle we can use. Cassidy?
Would BGF work?
BGF is this whole angle, which we could assume is 90. So BGF totally works. Eli?
BGA.
BGA is this angle right here, so that one also works. And we could call that BGA or BGD. It'd be the same angle. Questions? All right, I'm going to clear all this so this doesn't get too confusing. Now we're looking at for two angles adjacent to CEH. CEH. That's this angle right down here. Thomas, what do you think? You got one of them?
Yes. CEH.
Yep, adjacent to CEH.
BEC.
BEC. Ooh, change colors. BEC is right there. So notice I don't put the M, because I'm not talking about how big it is, how many degrees it is. I'm just talking about the angle. So here I just use the angle symbol. Abby's still sick. Feel better, Abby. That was a man. Everyone's dropping like flies. Bayla?
GEH.
GE what?
H.
GEH. Yeah, that's right here. So GEH will work. Luke?
BEG.
BEG will not actually. I'm glad that you said that, because if HEC, if CEH, my original angle's here, and you bring up BEG, that's this angle, they share the vertex, but they don't share a side. They have to share that side. So that, and we'll get to this in about 2 days, those are vertical angles. That pair would be called vertical angles.
Oh, okay.
There is another, though. There's actually two others if you really want to get creative. Bunger? CEG, the straight angle right here, would be adjacent. I'm not going to write it down, though. But also, on the other side, this straight angle, HEB, that would also be adjacent. But we normally try to not use straight angles. So when it asks you for only two adjacent angles, you'd want to use the red and the green up there, the HEG and the CEB. All right, Divine, you were out of the room, but we got to come back to you now. If we look at angle ABC, easy as 1, 2, 3. All right, so ABC, ABC
Just a line.
is that angle there. Can you name angles adjacent to ABC?
All of them.
Are there any angles up there that will share the same vertex, share a side, and not be inside of each other? BEG, that would have the vertex of E. They have to share the same vertex.
I know.
ABH would be inside of it. Orion?
FBH.
FBH is inside of it. Eli?
Everything is inside of it.
Everything that we see is inside of it. The only maybe possible would be CBA, the exterior angle. But since we've already used the straight angle, I would not use that. I would put here, nope,
Nope.
can't happen. All the angles are inside of it. We don't really like using straight angles. We like using really acute angles, seem to be the easiest to work with. Now let's check what they had for their solution.
But those are all inside.
And we're cheating.
They're all inside of it.
They lied to us.
Yeah, so we, in my use, we don't put angles inside of each other. They apparently are okay with it.
No.
I go back and forth on. So really all that, because they're thinking about the literal definition. The literal definition is shares a vertex and shares a side. So when you look at just sharing a vertex and sharing a side, you could be inside of each other. But when we talk about things that are adjacent, they're beside each other, but not inside each other. So we like to use just beside each other. Now, if you get on your homework, because it's through Pearson, if you get on your homework and there's no other options, you have to use an angle that's inside the other one, it's okay then. But know that when we talk about it, we like to define them as beside each other. So if we look at EOD here, we should all have enough practice to be able to figure this out. So take a second and write out all angles that you can that are adjacent to EOD. I don't know, I'm just writing these up here. I don't know how many there are. I'm just getting ready for you guys. So Divine, now there is an answer. And this should be easier than the last one I tried to give you. Can you give me an angle adjacent to EOD? Yeah. EOB would be this angle. Or, now this is where it gets tricky, and this is why when we discuss inside or outside, it's a little difficult to say whether the angle is actually inside. EOB could also be this angle. So there, it does put one angle inside of it, and that's where the definition gets a little gray. That's why we can kind of go back and forth. Because when I look at an angle, there's always two ways to look at it. Are you looking at the inside of the angle, or are you looking at the outside of the angle? So here, if I look at the outside, they are adjacent. The inside, they're still adjacent according to Pearson, but I don't like it when it's inside, really. So we'll put down EOB. Oriana? DOC. Right here. Katie, you got one for us? Which one? EOC could either be this angle, which Pearson just told us is okay, or it could be this angle. Either way, yeah, it works. Crystal? What is it? BOC actually cannot, and here's why. BOC would be right in here. It doesn't share either of the sides with the blue angle. Now, I'll give you a second chance. There is a BO that works, but it's not C. Hey, so what you're doing right now is rude. If I'm waiting for a student to think and figure it out, to say it out loud is rude. If you have it in your head, great, keep it there. Huh? BOD, right? Yeah, I said I was going to give you a second chance. So if I look at BOD, that takes me all the way to the shared side. So that will work. Hey, Cassie. Okay.
Okay, I put
AOE? Okay, so AOD would be here. Yeah, so AOD could work. But we could also have what you just said, AOE, because that will then be beside it. So do you guys see how there are many, many options when we start talking about adjacent angles? Because we can look at the smallest angles, or we can start combining angles into the bigger angles. So we're going to move on. There's probably even more here that we could list, but for now we are going to move on.
My ability to catch and eat fish has to do with the angles of my beak.
Parry
I have a perfect beak, by the way. Take a closer look. See that? 80 degrees right there.
So
And watch this.
He can open his beak. take
Now
90
I have two
degrees.
adjacent angles. Ha!
If his tongue is another ray inside of that angle, well, Perry just told us that the whole angle here is 80 degrees. So how do I figure out what x is? Brennan, what do you think?
You subtract 25 from 80.
Yeah, make sure we say it in the right order. To find this angle, it is the 80-degree angle without these 25 degrees. So we need to say, okay, the 80-degree angle total minus, actually I'll do this in green, the 25-degree angle that is right here leaves me with x being 55.
Degrees.
Questions on how we do problems like that?
No.
You just have to look at it and figure out what is it that we're trying to do. What do I know that I can use to solve it? So try this on your own. You're told the entire ABC, the big angle here, is 100. Now here, I would advise you to set up an equation. So I'm going to stop talking and write one more thing that you should be able to see. It's not.
No demons.
What? Well, do the work somewhere. We'll move on to those do you know how questions because this lesson we have time to do it, but do this somewhere. I apparently decided to chop that out of the notes for the other questions, which I don't know why I did.
The Illuminati made you do it.
When I look at those two smaller angles, the two smaller angles add up to the bigger angle. So I can write an easy sum equation. My angle ABD plus my angle DBC make my 100 degrees. So try to solve this. I'm going to pull up the notes so that we can keep going. Sure. What do you think? You were actually the next card, so that's ironic.
So, like, do you want me to say the equation, or?
Yeah. What'd you write out?
Okay, I put 2x plus 60
Alright, hold up.
100.
So ABD, Karina replaced ABD with the value of 2x. Then she replaced DBC with the 60, and that equals the entire angle 100.
And then you would do the inverse, so you would subtract 60
We
by
s-
100 by itself.
We subtract 60 from itself and from 100.
That's 40. And
That
then you-
gives me, well, I'll keep it color coded. 2x equals the 100. Or, sorry, now what do we get 2x is equal to? 40. So actually I should probably write that in black because it's not the big angle.
And then you divide 40 by 2. And you
We divide by 2. And we get that x must be 20. Now x does not get the degree symbol because x is in my degrees. It's part of what makes up that angle. So 2 times the value of x makes that angle 40 degrees. And we can check our work because if that angle would be 40, 40 plus 60 is 100, it checks out just fine. Questions, comments, concerns?
No.
Sweet. So, our close-in check, which I went ahead and put on your notes today because we have time. I don't know why that won't go away. This week's math counts problem. So we want to use this diagram, and this diagram with all these 8 angles kind of leads us to tomorrow's lesson. By the way, I'm not certain whether your mastery will be tomorrow or Friday for chapter 9, so just please try to make sure your work is done. You've had plenty of time to get it done.
If it's tomorrow, can we see the quiz?
No.
Oh.
I mean, well, we'll see how long these take. I've got it made. So, name 2 angles adjacent to angle 2. So if we look at angle 2 here, what angles are beside it? Sharing a vertex and sharing a side. Is there? Angle 3 and Layla? Angle 1. Now this is why I tell you not to put angles inside of each other. Is there an easy way to express this angle? No. Right now that would be angle 1 plus 2. Like what? It's not nice. So that's why when we talk about adjacent angles, I prefer that we just work B side, not inside. Now what about 2 angles adjacent to angle 5? Bunger?
6.
And Oriana?
I actually have a question. Is there another one for angle 2?
Which one do you
4?
think? 4
Oh,
doesn't
never
share a
mind.
side.
Never mind. Okay.
And do you have the other adjacent angle to angle 5 though?
8.
Yep.
Yeah. Oh my gosh.
Now, this is kind of introing tomorrow. So, angle 2 and angle 1 up here together form what? They form a straight angle, right? That's a straight line. Also, angle 2 and angle 3, what does that pair form? Another straight angle. So what could you say about angle 1 and angle 3? If 2 plus 3 equals 180 and 2 plus 1 equal 180, what could you say about 3 and 1? So 2 and 3 is a supplementary pair. 2 and 1 is a supplementary pair. But because 3 and 1 both can pair with 2, they have to be equal. They've got to be, bless you, they've got to be the same thing in order to be able to do the same thing. This leads us to our next classification of angles called vertical angles. Tomorrow we're going to talk more about vertical angles. I've still got 5 minutes left. But tomorrow we're going to talk about vertical angles. Vertical angles have to share the vertex, and they also have to share the 2 sides that make them their angles. So notice, angles 1 and angle 3 both share those 2 lines. Those are the only 2 lines that they both use. They are going to be equal to each other. So that's a little preview for tomorrow where we're headed. They're going to be equal. Since we can see it, let's just move on to number 3. If ABD, the whole angle, is 40 degrees, Cassidy. Okay, what do you think? Sure.
So I did 40 minus 25, and I got 15.
So angle ABC, or the value of x, is 15 degrees. Questions? Very good. Capture that. All right, we're gonna check the error analysis. So JKL, I'm gonna label what they tell me. JKL is 125 degrees. The equation 3x plus 5 minus 40 equals 125 was written to find the value of x. Zach, you are actually the only person I haven't talked to yet today. Is that equation right? Or is there an error that we need to fix? Is this equation right if I'm trying to find the value of x? Is that equation what I want to use, or did somebody mess up? So they've got their 3x plus 5, which is this angle right here. And then they've got their 40, which is this angle right here. What do you think, Zach? So 3x plus 5, what would you do if you were building the equation? Forget about their equation for a second. You were building the equation to express this. We start with our little angle, 3x plus 5. What would you do next then? Plus 40 will equal the full angle of 125. So was there a mistake in their equation? Yeah, what was their problem? They should not be subtracting 40. They should be adding. So now, let's solve this. Zach, what would I do first? Close. You're making the mistake a lot of people do. Combine like terms first. You were jumping too quickly to solving. So we combine the like terms. That becomes 45. Now, you could have taken away the 40, but then you would have still had to take away the 5, so just to save a step. So if we take away the 45 from both sides, we get 3x is equal to 80.
Yeah.
And we then,
And it makes 2.6 repeating. Or 26.
or we can use a mixed number.
Or 26 and 2/3. Yeah. Ooh, that's a fraction.
26, it's a mixed number.
No kidding. Fraction.
Oh my god.
It's a whole number with a fraction. That's a mixed number.
Yeah.
26
It has a
and
fraction.
2/3.
It has a fraction.
Questions, comments, concerns?
No.
So, I will show you guys what's going to be on your mastery tomorrow. Well, okay, so here's my debate. I need to pull the grade report still and see how people are doing because your homework should be pretty darn close to done. I was discussing with a student this morning, so I want to let all of you guys know, you should always finish a chapter worth of homework before moving on to the next chapter. So if you still need to do 9.4 or 9.5, anything like that, or God, if you still have to do 9.3 or 9.1 or 9.2, that's really bad news, Bears. You need to get that stuff done before you work on the chapter 10 work because the mastery is coming up soon. So get that work done. All right, we kind of are out of time. Yeah, talk to me later if you really want to see it, but it's not bad.